All right, we're going to talk about some properties of sine and cosine that hopefully will make things a little bit easier in the future. So let's take a look at this diagram here. I have this triangle, the standard triangle here in the first quadrant where this is theta. You have x and y and r, typical. But I've also put the ray down here in the fourth quadrant where if you were going in the clockwise direction, this would be considered negative theta, where we still have x and r, but now we have a negative y because we're going down into the fourth quadrant. So if we look at the first triangle right here and we evaluate what the sine of theta is, the sine of theta is going to be y over r. Now if we go back down here into the fourth quadrant and we want to evaluate the sine of negative theta, now it turns into negative y over r. Okay, so that's interesting to see. Let's try it out with cosine. The cosine of theta is going to be x over r. And then looking down here in this bottom triangle in the fourth quadrant, the cosine of negative theta, well, that's also x over r. So that didn't change at all. So what we can take from this is that the sine of negative theta is the same as the negative sine of positive theta. So whatever the sine of theta is, you would just make it negative. And then the cosine of negative theta is the same exact value as the cosine of a positive theta. Okay, so this is what you're going to need to memorize. Okay, we're going to use that a lot in the future. But this concept is actually something that translates into all functions. You can classify a function as being either odd or even, or sometimes it's neither. And the idea is that if you take your function and evaluate it at negative x, and it comes out to be the exact opposite of your function evaluated at x, that is considered an odd function. Whereas an even function is if you evaluate your function at negative x, you get the exact same thing as the function evaluated at positive x. So you can see that sine and cosine can be classified as being odd and even functions. Okay, so let's actually take a look at this outside of trig. If you have f of x is equal to x squared, is that odd or even? So how do you test it? Well, what you're going to do is you just plug in, you change the x into negative x, and you evaluate. So f of negative x gives you a negative x quantity squared, and this negative gets squared, so it becomes a positive, so you get x squared. So now you compare this answer with the original, and you notice that this and that are exactly the same. So that follows this type, which means that it is an even function. Okay, so let's try something here. F of x is equal to x cubed. Is this odd or even? So we're going to do the same process. You plug in negative x for x, and this time a negative, when you cube it, gives you a negative 1, right? And then x cubed is x cubed. And so now when you compare these two, you can see that this is the exact negative of that value. And so that makes this an odd function. So you'll get some practice with functions, f of x, and different functions that we've looked at in Algebra 2 to test them to see if they're odd or even. Okay, so going back to trig, sine and cosine, the type of question that you might encounter, they might tell you the sine of 60 degrees is root 3 over 2. And they say, figure out what the sine of negative 60 degrees is. There's actually no calculation needed to be done. You don't need to draw a triangle. You just use that property that the sine of a negative angle is equal to the negative of whatever the sine of the positive angle is. So we were given that the sine of 60 is root 3 over 2. So the sine of negative 60 is a negative root 3 over 2. You just make it negative. Okay, let's try this one. The cosine of 45 degrees is root 2 over 2. So then the cosine of negative 45 degrees, remember that for cosine it doesn't matter if the angle is positive or negative. It's just going to be the same thing. Okay? So now we're going to take this out to a bigger scale. Instead of just dealing with theta and then negative theta, what happens if we're in any one of the quadrants and we relate it to 180 plus or minus theta or 360 plus or minus theta? Okay, so really what you simply have to think about, you don't have to memorize all this stuff, is just go back to your all students take calculus. and just envision, hold on one second. Okay, sorry about that. My sister walked in and we had a conversation, and I have no idea what the last thing was that I said. Anyway, I'm going to pick up where I think I left off. So using all students take calculus, we can just think about what quadrant we're in based off of the theta they give us in relation to 180 or 360 degrees. So for example, if you know that the sine of theta is y over r, the sine of 180 minus theta, well, think about that. 180 minus theta is going to put you over here in the second quadrant, because you would go a full 180 and then subtract theta means you're going backwards a little bit, puts you up here. So this is the S quadrant, so sine is positive there, so it's going to give you a positive y over r. If you were dealing with cosine, though, cosine is negative, so that would be a negative x over r. Okay, so everything should be in relation to theta, and theta is like your reference angle. All reference angles are going to be congruent with that same problem. Okay, so what happens if you're dealing with radians? Because all these examples have dealt with degrees, but we're also dealing with radians as well. So remember that 180 is the same as pi radians. So you could just replace all of these expressions with pi or 2 pi instead of 180 and 360. So if we did the sine of pi plus theta, well, pi plus theta, that's 180 plus a little bit, puts you down here into the third quadrant. So sine is negative and cosine is negative because tangent's the only one positive. Okay, now the sine of 2 pi minus theta, well, 2 pi minus theta, that's like going a full rotation and then subtract a little bit. That puts you down here in the fourth quadrant. So sine is negative, but cosine is positive. Okay, so let's actually put this into practice with numbers, not just ratios of x and y and r. Okay, so they're going to give you the sine of some angle, whether it's in degrees or in radians, and they're going to evaluate it for you. They're going to give you the decimal equivalent. And they'll give you this table with thetas all over here in the left-hand column, and you have to figure out what the right-hand column is, which is the sine of theta. So all you really have to do is figure out each of these angles, which quadrant they're in, and then is sine positive or negative of this decimal. So here's pi over 10. This is theta. Negative pi over 10 is going to be down here. So we know that sine is negative down there, so this is just a negative of 0.306. There's no calculating involved in these. You don't need a calculator at all. Okay, so 9 pi over 10, what you have to think of, 9 pi over 10, well, that's just a little less than 10 pi over 10. And 10 pi over 10 is pi. So it's like taking pi and subtracting your theta puts you right here into the second quadrant. So second quadrant sine is positive. That means we have a positive 0.306. Okay, the next one is 11 pi over 10. So 11 pi over 10 is the same as, say, 10 pi over 10 plus 1 pi over 10. So this is just a little bit more than pi. That's going to put us down here in the third quadrant. And so now sine is negative there. So it's a negative 0.306. The last one, 19 pi over 10. Well, this is just a little bit less than 20 pi over 10. Well, 20 pi over 10 is the same as 2 pi. So it's like 2 pi minus theta, which puts us down here into the fourth quadrant, and sine is negative there as well. So negative 0.306. All right, so you'll have a bunch of these to practice with. Just remember, think of these angles in terms of what quadrant they're in. Is it a little less than pi, a little more than pi, a little less than 2 pi? Maybe it's a little more than 2 pi. So maybe you had 21 pi over 10, which would put you up here. And then just do your all students take calculus and figure out if your sine, or maybe this is cosine, is positive or negative. All right, that's it for properties of sine and cosine. Good luck.